One of the wonders of the jet engine is its ability to produce a strong enough thrust through the air medium. But how can a jet engine produce such a strong thrust? This video will discuss how a jet engine works, but after this one. So jet engines work using the principle of Newton's third law, which states that action equals reaction. So when a turbine spins, it blows air to one side, making the air move away from the turbine. The reaction is that the air on the other side moves towards the turbine, giving the turbine a pushing effect and the force to move forward. This is the basic principle of the jet engine. But how is this principle able to move a very heavy aircraft? In a turbojet engine, a combustion process is used, producing a thrust force that is used as a thrust action and also to move the turbine itself. First, we have the compressor turbine. The compressor turbine is a series of fans that function to compress air. Why must it be compressed? The reason is that combustion can occur spontaneously and the energy released is also large, so the air must be in a state of high compression. The fan used in the turbine has slanted fins and many fins, so that when it rotates, the air is blown backwards. This series of compression turbines consists of two types: static turbines and dynamic turbines. Static turbines are stationary, while dynamic turbines are rotating. Both types of turbines are installed alternately, allowing the air pressure to increase further back. In one jet engine unit, there are usually two series of compressors, a high-pressure compressor and a low-pressure compressor located at the front. These two series of compressors are located in different portions, resulting in different rotations. Additionally, the direction of the fins is also different, allowing the rotation of low pressure and high pressure in different directions. Behind the compressor turbine, there is a combustion chamber. The combustion chamber is a small air channel where air comes out of the compressor turbine. Here, an injector is installed to spray fuel. Because the air has been compressed, the injector only needs to spray fuel. The high temperature of the compressed air burns the blown fuel, producing a high-power backward thrust. Behind the combustion chamber, a power turbine is installed, serving as the driving force for all the turbines in the engine. Since its position is behind the combustion chamber, the power turbine is hit by the combustion jet, causing the turbine to rotate. Here, there are also two types of turbines: high-speed turbines and low-speed turbines. Both types of turbines have opposite fin directions. High-speed turbines are mounted on a shaft connected to a high-pressure compressor, while low-speed turbines are mounted on a shaft whose axis is located inside the first shaft, connected to the low-pressure turbine. Although this circuit appears to be connected to one axis, it is not. There are two axes that make the movement different. The first and second shafts are connected through a planetary gear mechanism, allowing them to be connected despite their opposite rotation directions. Additionally, there is an extra shaft from the low-pressure compressor to a giant fan. This fan serves to increase the thrust of the jet engine. As a result of this combustion, a significant amount of energy is stored. Some of this energy is used as thrust, but more energy is used to turn the power turbine. Because the turbine power receives a large portion of energy, the fan in front can spin very fast. This effect sucks air from the front and flows it in. Some of the air goes into the turbine compressor, and the rest flows through the side of the engine to the back. The air blown from the fan provides a cooling effect on the engine, as well as increasing its thrust. As a result, the engine can have enough thrust to launch the plane at high speed. The type of engine discussed earlier is a turbofan engine, which uses a fan to flow high-pressure air. That's an animation of how a jet engine works. Hopefully, it can increase our knowledge. subscribe, and thanks for watching.